Design and Technology. Unit 1, Module 2. Lessons 7 and 8. Evaluate designs and examine the benefits of using evaluation techniques/methods to assess designs. Lesson 7. Evaluate designs. A. Methods used to evaluate designs. SWOT analysis, strengths, weakness, opportunity, and threats. Design testing methods, A/B testing, survey, beta testing. Material testing. Performance testing. Usability testing. B. Factors to consider when evaluating designs. Needs. Function. Aesthetics. Budgetary allocation. Ergonomics. Obsolescence. Life cycle stages/analysis. Environmental consequences. Functionality and appropriateness. C. Success and failures in design solutions. Look deeper into aesthetic. Designers may consider the aesthetic impact of customer appeal, shape, color, texture, form, feel, smell, surprise and delight features. Fashion, culture, history, trends. Future expectations, rate of change in technology, trends, product families. What to consider with ergonomics. Man-machine relationships. Operation. Height. Layout. Comfort. Lighting. Functionality. Overall geometry, size, width, space, arrangement. Motion of parts, type, direction, velocities, acceleration, kinematics. Forces involved, load direction, magnitude, load, impact. Energy needed, heating, cooling, conversion, pressure. Materials to be used, flow, transport, properties. Control system, electrical, hydraulic, mechanical, pneumatic. Information flow, inputs, outputs, form, display. Life cycle stages/analysis. Environmental consequences. A look at the life cycle and environmental consequences were studied and presented on the Open Education Resources, OER, Commons website. The video link is documented in the resources section of this presentation. Let's watch the video.
Assessing and reducing the life cycle impact. What are methods to assess the impact of the life cycle of a product or process? What are advantages and disadvantages of each method? What are the inherent limitations of these methods? These are the questions that we'll look at in this video. How would we holistically assess the impact of a product or a process? There are two main approaches: life cycle assessment and eliminating risk. Let's focus on the life cycle methods. Life cycle assessment is a concept and methodology to evaluate environmental effects of a product or activity holistically. In all the life cycle methods, the system boundaries around the life cycle is shown. The general goal of a LCA is to produce some type of indicator for the purpose of assessing the impact, or ideally identifying ways to redesign for a lower impact. In full LCA, after defining the scope of the study, one inventories the inputs and outputs for the entire life cycle. The next step is to convert the life cycle inventory to impact categories such as global warming, acidification, aquatic toxicity, and human health. To convert this LCI to an assessment, one then quantifies the impact of the life cycle by weighting each category of impact and summing the weighted factors to produce an eco-indicator. Note that the weighting process implies a value system of which of the categories are more damaging. This is an area of controversy around the LCA method. At the time of this video, LCA is a methodology of computing impact that, like all methodologies, is limited by the assumptions and data available. A shortened process is the practice of streamlined LCA developed by the Natural Step. The Natural Step framework identifies types of capital: natural capital, social capital, human capital, and economic capitals, which are financial and manufactured. The TNS framework is based on 4 principles that sustainable actions will not subject the Earth to increasing concentrations of substances extracted from the Earth's crust, concentrations of substances produced by society, and degradation by physical means, and that people are not subject to conditions that systemically undermine their capacity to meet their needs. In the streamlined LCA process, one creates a matrix of each stage of the life cycle against the sustainability principles. This matrix is then used to rate each of the life cycle stages against each of the 4 criteria. This method reveals possible high-leverage intervention points within the life cycle. One of the limitations of the technique is that it requires a great deal of a priori knowledge about the impacts. It is also limited to known practices for which the impacts can be rated. The economic input-output method uses aggregated data from business sectors for the inputs to the particular product. This aggregated data is used to determine a particular output measure, such as metric tons of CO2 equivalent produced. In this example, $1 million of leather goods are produced and require the 7 inputs from the different industrial sectors that are shown. The output is around 2.4 thousand metric tons of CO2 equivalent produced. This method provides a quick and approximate value for the intended product, but since it is based on aggregates for industrial sectors, it does not allow designers to compare designs when the innovation is within the same industrial sector. As in the case of this leather example, you will not be able to compare power generation and supply for only renewable energy, since the energy sector is aggregated across all energy resources within the industry sector. Design strategies that use the life cycle assessment methods usually focus on changes in the domain of physical things, such as materials and processes. This strategy to reduce impact usually consists of an iterative process of design, assessment, and redesign. There's a way in which this focus on choosing the less impactful, because it relies on known industrial era methods of production, can result in only incremental improvements using the same industrial era methods. The LCA methods don't necessarily promote transformative innovation. There are 3 common methods for assessing the impact of the life cycle of a product or process. Full LCA has the advantage of comprehensiveness and accuracy with the disadvantage of cost. Streamlined LCA is qualitative yet provides a look at intervention strategies for redesign. Economic input-output is quick and approximate and based on aggregated data for different industry sectors. All LCA methods generally promote incremental improvements in materials and processes that are based on known technologies. In the next video, we will look at design strategies for transformative innovation for sustainability.
Engineering design process. Evaluate solution. Evaluate the results and ask, what changes need to be made? Pursue an entirely different solution? Make minor change? Focus on making your solution better. Lesson 8, examine the benefits of using evaluation techniques/methods to assess designs. Inform business decisions to identify potential success barriers/blockers that inform future designs. Improve designs. Refine design approaches.